here. A line that intersects a circle in exactly 2 points is called a secant. In the figure above, S, F, and EF are secants of the circle. And they show you the circle up there. In this one, A, B, and CD are secants of the circle. When two secants intersect inside a circle, the angle formed are related to the arcs they intercept. So, they form vertical angles, right? So you'll notice that A, B, and CD form vertical angles here. So we know these two angles are going to be the same measure. And specifically what happens is this angle, like angle 1 that's created, is exactly half of the two arcs that it has intersected. So if I take arc AC and add it to DB and cut that measure in half, I'll get 1 and its vertical angle because they're the same. For 2, if I take the arc AD, add it to the arc CB and cut that sum in half, I will get the measure of 2 and its vertical angle as well. So when you have secants, it is half of the sum of the arcs that it intersects, versus the tangent that we learned, which is half of the arc that it intersects. All right, so let's look at how we use it. Turn the page. Example 1. Find the measure of 2 if the measure of BC is 30 and AD is 20. All right, so there are a couple ways you can do this. They want 2. We have exactly what we need to solve for 1, right? We're going to add these 2 and cut it in half. We'll get 1. 1 is supplementary to 2. Those are linear angles, right? So once I find 1, I can subtract from 180 and get 2. The other method would be to take this 50 and subtract it from 360. And that should be the measure of these 2. And then you could cut that in half and get 2. But there's 2 methods, whichever way. Personally, my method, I would start with this and solve for 1 and then just subtract out. Like that's how my brain would want to do that. But there's multiple ways to do it. So for this one, I would say let's solve for 1. So the measure of angle 1 should be exactly half of the 2 arcs that it intersects, which are these 2. So I would say half of 20 plus 30. That's 50 divided by 2. I'm going to get the measure of angle 1 is 25 degrees. Since I'm solving for its supplement, so the angle that is right next to it, I would say 180 minus 25. That will give me 155 degrees, which is my answer here. The measure of angle 2 then is 155. Does that make sense? Question. So in that case, we had 2 secant lines intersecting each other. A secant can also intersect a tangent at the point of tangency. So we have this tangent line here, and then we have a secant line that is intersecting it right here at the point of tangency, which is that B, point B. Angle ABC intercepts BC at DBC intersects BEC. Each angle has formed a measure half of the arc that it intersects. So we have 2 different angles here that have been formed. We have the angle ABC, right? That is intersecting this arc right there. That will be half of that arc, okay? We also have another angle, right? We have angle CBD. We have the one on this side, and it intersects this arc. So that one will be half of that arc, all right? So if you have a tangent and a secant that intersect at the point of tangency, you create this one arc, and it's half of that one arc. So it's just like your tangency almost, your 2 tangents that intersect. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is half the measure of the intercepted arc. All right, so let's look at that example. We have, okay, so it says find ABC if the measure of AB is 102. All right, so we have to look and see what arc they're talking about. They are talking about the angle ABC. All right, and so if we're talking about that angle, the arc that that angle intersects, meaning the one that's on the inside of that, the one that intercepts is this one right here. They gave us 102. 102 is not what we need. How do we get what we need? A whole circle is what? 360. So I'm going to say 360 minus the 102. That will give me 258. So that means this arc here is 258. And now I know that the angle itself should be 1/2 of the arc that it intercepts. So 129 would be my angle measure there. So secants can actually intersect outside of the circle. Tangents and secants can meet outside of the circle as well. So you have these options. You have two secant lines where they cut through the circle at 2 points, but they meet outside of the circle. So the vertex of the angle formed is outside of the circle. That option can happen. We have a secant and a tangent. Again, secant cuts through it, tangent touches it at 1 point, but they meet outside, so the vertex here is outside. And then we have two tangents. Also, they touch at 1 point, but they meet outside. How you calculate the angle that's formed is exactly the same. You take the outside minus the inside here, which is what they have here, DE minus BC, and you cut that in half. For the next one, you would take this DC arc minus this BC arc, and you would cut that in half. And then for this third one, you would take the arc BDC, you would subtract the arc BC, and you would cut that in half. So when they meet outside of the circle, they have two arcs that are formed, and you take those, subtract, and divide by 2. This is just straightforward. They've given us all that we need. X is 2 secants. The two arcs formed are 120 and 50. So I'm going to say that X should equal 1/2 of 120 minus 50. 120 minus 50 is 70. So X should be 35 degrees. All right, let's look at this one. This one's going to make you think a little bit outside of the box. Suppose a geostationary satellite S orbits about 35,000 kilometers above Earth, rotating so that it appears to hover directly over the equator. Use the figure to determine the arc measure of the equator visible to this geostationary satellite. Okay, so they want us to find X and all of that verbiage there. They want us to find this part right here, X. And they're actually asking for the arc here, how much of the Earth. We need to know both of them because we only know the relationship between this and both of them. But the entire Earth, we're, assuming that it is circular. It's a little bit oblique, but that's okay. It's 360 degrees, right? So if I'm solving for this, I need this other piece. How do I know how big this is? In terms of X, how big is it? So this outside part is going to be 360 minus X, right? And I need to subtract this inside part, which is X. That right there is my formula to find this. Yes, so my angle is exactly half of this arc minus that arc cut in half. That's what we just decided, correct? And I actually have everything I need here to solve. So I'm going to, actually would multiply both of these by 2, 22. And then I can just combine like terms. I have a negative X minus an X. So I have 360 minus 2X. What's my next step here? Subtract my 360, right? So I'm going to get negative 2X equals what? Hopefully that. And then divide by negative 2. So X is going to equal 169, not 66, 169. So they want us to find X, all right? For this particular one, I know that 45 should be exactly half of this arc minus that arc, correct? Now this arc is very specific. The chord that also cuts this arc has been given. That chord is a specific type of chord. What type of chord is that arc created by? What is that called from W to V? The diameter, right? What do I know about the arc created by a diameter? It's 180, right? So I know that this right here is 180. So I know that the angle, 45, should equal 1/2 of 180 minus the 10x. And again, I really have everything that I need to solve this. Multiply both sides by that 2. So I have 90 equals 180 minus 10x. Subtract my 180. Negative 90 equals negative 10x. So x is going to equal 9, which is what they were asking for us to solve. Had they asked for the arc measure, you would have plugged it back in, but they were just asking for x here. So this is x. This is what's left over in the circle. So that's 360 minus x. Yes? So 55 should equal half of the big one, x, minus the little one. So 55 equals half of x minus 360 minus x. You have to distribute that negative. So negative 360, positive x. So x plus x is 2x. Or minus a negative, however you look at it. Minus 360. Add your 360 over, that's 470 divided by 2. That's 235.